All right, hello everyone. Welcome to your first asynchronous lesson. I'm going to try and keep this short and sweet, so let's just get right into it. Today we're going to talk about what matter actually is. So for our learning objectives, by the end of this lesson, you should be able to define matter, you should be able to differentiate between substances, mixtures, elements, and compounds, and we'll talk about all those. You should know the four major categories of elements, differentiate between ionic and molecular compounds, differentiate between homogeneous and heterogeneous mixtures, and then just be able to use a simple particle diagram to differentiate solids, liquids, and gases. All right, so this is a sample regions question, and we'll come back to this at the end after we've taken the notes. All right, so chemistry, the majority of what we'll be talking about is the periodic table. But before we get into that, let's talk about what matter is. So matter is anything that is, matter is anything that has mass and has volume. So matter can be divided into two categories. We have pure substances, and then we also have mixtures. So we'll talk about pure substances first, and then we'll get into mixtures. For our pure substances are anything that is essentially just the same thing. So you only have one. If it's pure, it means you only have one substance in there. So pure substances would be elements. And so the elements are anything found on the periodic table. So these are kind of like the basic building blocks of matter and of everything. There's a few different types of elements. So if you've taken any science class before, I'm sure you've heard of the elements. But there's a few different categories of elements that you need to know. And so for these categories, there are metals, there are nonmetals, and then kind of in between metals and nonmetals, we have metalloids. These are also known as semimetals. And then lastly, we have the noble gases. There are more categories, but these are the four basic ones that we'll be talking about. So if you look up at the periodic table is actually kind of divided into those four categories. So our metals are right here. Those are all the metals. Notice that hydrogen is not a metal. Hydrogen is actually part of the nonmetal group. So our nonmetals, including hydrogen, would be all these guys. Those are the nonmetals. Now in between everything here that's listed in brown, and I know you guys have your own periodic table, so if you want to color code these yourself, that's totally fine. Anything in here, these are the metalloids. So these are metals. Over here we have nonmetals. And then this last group, way over here in the end, these are the noble gases. Okay. Now the other category of pure substances, we also have compounds. So compounds are essentially when you have, I'll define it here, so we have two or more elements, and these are always found in a definite ratio. So what that means, if you have, for example, water is H2O. What this means is that you will always have 2H, which is also known as hydrogen, in a 2-to-1 ratio with oxygen. So O is oxygen. So that's what it means by an indefinite ratio. There's two different kinds of compounds. So we have ionic compounds, and these would be, this is when you have a metal bonded, and we'll talk about what that really means later on, bonded to a nonmetal. So an example, if we go up back to our periodic table, if we have Na bonded to Cl, that's a metal bonded to a nonmetal, and so that would be an example of an ionic compound. The other type of compound would be a molecular compound. And so this is when you have a nonmetal bonded to another nonmetal. And so examples here would be like H2O. So again, going up back to our periodic table, hydrogen, again, is over here. That's a nonmetal. Oxygen over here, that's another nonmetal, so bonding those together would result in a molecular compound. Another example would be like carbon dioxide or CO2. So sorry if I'm making you dizzy here. Carbon is right over here, element number 6. That's again bonded to oxygen, so those are two nonmetals bonding together. And you can, again, always pause this video when you need to. Okay, so that's kind of it for our pure substances. Let's talk about mixtures now. So mixtures is when you have, obviously, a mixture of two or more substances. So a mixture is just two or more substances, and there's two kinds of mixtures. So we have homogeneous or homogeneous mixtures, and this is essentially a mixture that is the same throughout. An example of a mixture that is the same throughout would be something like Kool-Aid. So when you mix that Kool-Aid mix in the water, it's not unevenly distributed. That Kool-Aid is evenly distributed throughout that water, and so it is the same throughout. We call that a homogeneous mixture. Another example would be, or another type of mixture would be a heterogeneous mixture. And so this is when you have visible parts within the mixture. So examples here would be something like a garden salad. And then the example that everyone uses is Italian dressing. So if you look at Italian dressing through the bottle, you can visibly see the different parts. That's a heterogeneous mixture because it's not the same throughout. All right, let's transition a little bit here, and we're going to talk about now the phases of matter. So we just finished talking about classification of matter. Now we're going to talk about phases of matter, and then we're also going to talk a little bit about particle diagrams. These kind of go hand in hand. So the phases of matter, as you may already know, are solid, liquid, and gas. There's also plasma, but we're not going to get into that in this class. So solids, when you draw what's called a particle diagram, we're using usually little tiny circles to represent the particles. So when we draw a particle diagram of a solid, you're going to draw those circles nice and compact, tight together. Those particles are not really moving around, they're just in one solid crystal structure. Now for a liquid, when you draw a particle diagram for a liquid, they're going to be a little bit more spaced out, but they would still be, if these were in containers, the liquid particle diagram, you would still have all those particles at the bottom of the container, right? There's no liquids floating around or like hovering or in the gas phase. So when we draw a gas, if we draw our container first, your particles of gas will be, they're going to take up the space of that container, and so they're going to spread apart. All right, and we can also represent mixtures as particle diagrams too. So when we're talking about mixtures, if you have a particle diagram that looks like this, this would be a pure substance because all of those are the same, but sometimes these will be filled in together. Some of them will get filled in, and so this would be representing a mixture. You can also have particle diagrams to represent compounds. So sometimes you'll have particle diagrams that look like this, where one of these will be filled in. And so this is a representation of a compound because you would have this equals, that would be something like element A, and then this would be representing element B, and so these would be representing compounds of A bonded to B, and so that's what that would represent. All right, so let's go all the way back up to the top of our notes, and let's answer the sample regions question. So it says, given the sample representations for atoms of two elements, we can see that the clear circle represents an atom of an element, and then the black circle represents an atom of a different element. And the question says, which particle diagram represents molecules of only one compound in the gaseous phase? So remember, compounds are two or more elements bonded together. So the compounds, it would not be A and it would not be B, because those do not represent compounds. All of these are actually in the gaseous phase because you can see that the particles are floating around in that container. And so we're only looking for one compound. So if you compare C and D, D has compounds that look like this, but it also has compounds that look like that. So that would be a mixture of two different compounds. But C would be our answer because all of these compounds are exactly the same.